We will begin this experimental procedure by ascertaining the mass of the red pascar utilizing the electronic balance. Next, one end of the dynamic track should be elevated using the metal stand and the relevant mounting hardware. On the elevated end of the track, the GLX motion sensor should also be attached by sliding the sensor over the end of the track. Since the motion sensor utilizes ultrasonic sound pulses to determine the position of objects, it is important that the face of the sensor be positioned perpendicularly to the dynamic track. We also want to calibrate the sensor for close-range measurements, so the switch on the side of the device should be set to the car icon, not the person. With the motion sensor connected to the GLX, we will navigate to the home screen, then to the Sensor tab. Before using the motion sensor, we will change the sample rate to 25 samples per second, and we will ensure that only velocity is made visible on our final data plot. Selecting the Home button again, we will then navigate to the graph screen. Before we start racing pascars down the inclined track, we need to determine the slope of the track. To do so, we will use a meter stick to measure the height from the table to the top of the track at both the 30 and the 80 centimeter marks. Once we have this information recorded, we are ready for our first data collection run. We will position the pascar at the top of the inclined track, with the edge of the car just above the 30 centimeter mark. Then, in quick succession, we will press the play button on the GLX and release the pascar. A diagonal plot of velocity versus time should begin to appear on the GLX as the car travels down the track. Once the car is beyond the 80 centimeter mark, the play button should be pressed again to stop the data collection. The resulting graph on the GLX should be a relatively straight diagonal line. The F1 button can be used to rescale the plot, and depending on how quickly you started and stopped the data acquisition, you may notice some spikes or irregularities at the beginning or ends of the plot. To collect your two data points from the plot, we want to move the cursor to one end of the plot and then to the other end, but it is important that the cursor remain positioned on the linear portion of the plot and not the irregular sections at the end. Ideally, your two data points you choose to record should be as far apart as possible without straying into the irregular sections at the end of the data plot. Since each data point is a coordinate representing both a time and velocity, the average acceleration of the pascar can then be calculated. To gather another data set, we will loosen the set screw on the mounting hardware and raise the track slightly. Remember to measure the heights from the table to the top of the track and at the 80 and 30 centimeter marks. Then release the pascar, just as before, while the GLX motion sensor is activated. A total of 5 different data sets should be collected for this part of the experimental procedure. For this, the second procedure, we will determine the mass of the blue car. Then, we will remove the dynamic track from the stand and use the threaded adjustable foot to ensure that the track is level. A pascar placed on our track should stay put, with any directional bias compensated for by adjusting the threaded foot until the car consistently does not move. To create the initial setup for this procedure, we will make sure that the motion sensor is still properly mounted to the end of the dynamic track, with the sensor face aligned perpendicular to the track. Then we will place both the red and blue pascars on the track with their black Velcro pads facing each other. The blue pascar should be closest to the motion sensor, with the end of the car without the Velcro pads at least 15 centimeters away from the face of the sensor. You should attempt to duplicate this initial experimental configuration for each of your data collection runs, with the only change between each run being the distribution of the two rectangular masses. For this first run, we will place both of the masses in the red pascar. To collect our first data set, we will make sure our GLX is still on the graph screen. Then we will press the play button and gently push the blue pascar towards the red car. Once both cars collide and travel some distance together as a combined entity, the play button may be pressed again to stop data collection. Similar to the previous procedure, some inconsistent or noisy data spikes may be visible at the beginning and end of the data plot, but in this case, there should be at least 2 distinctive horizontal lines. The first higher line represents the blue car's initial velocity before the impact, while the second lower line represents the final velocity of the combined blue and red pascar. Using the cursor, we will determine and record the initial velocity of the blue car, and then the final velocity of the combined cars. To complete this procedure, we then change the mass distribution between the two pascars, keeping all other variables consistent. For the next mass distribution, we will remove one of the masses from the red car. Then we will remove the other mass from the red car so that neither car has any added masses. The fourth configuration will feature one mass added to the blue car, similar to the last mass distribution. For the next setup, the blue car will be given both masses. For the final mass distribution, one mass will be moved from the blue car to the red car so that each car has one added mass. Utilizing nearly the same setup as the previous procedure, this final procedure begins with the pascars placed in the same general orientation. The blue car should be placed closest to the motion sensor, with the red pascar near the middle of the track. But this time, the Velcro pads should not be facing each other. Instead, small but powerful magnets embedded within the vehicles will simulate an inelastic collision. We will also use the same sequence of mass distributions to be consistent between the second and third procedures. This means that for the first dataset, both masses should be placed in the red car. Just as before, we will press the play button on the GLX, then we will give the blue car a small but firm push. Notice as the cars interact, a completely different result occurs than in the previous procedure. Before fully considering what has occurred, make sure to stop the data collection once the cars have traveled some distance after their collision. If we examine the data plot of this collision, we can see the initial horizontal velocity line for the blue pascar, but instead of connecting with the other pascar, the blue car bounced off of the red car. This interaction is represented by the second horizontal line in our plot, which suddenly dips below the zero line into the negative graph space. This should also correlate with what you observed when the vehicles collided. Utilizing the same sequence of mass distributions from the previous procedure, we will complete all the necessary data collection runs for this procedure as well.